Hi. Now in this video tutorial what I'm going to show you is how we can use the sine rule to find an angle in a triangle. And that triangle generally is a non-right angle triangle. Now suppose we had to find one of these three angles. Let's say we had to find this one up here. Let's just label it with the Greek letter theta. Well, in order to find an angle in a triangle using the sine rule, you must know what I often refer to as opposites. You must know the opposite side to the angle. That is this side here. So let's just say it's 8.2 centimeters. Now this is not sufficient information to find out this angle using the sine rule. What you need to have is another side and its opposite angle. So in other words, you might know this length and its opposite angle, this one here. Or you might know this length and its opposite angle, this one here. Well, let's just suppose we know this length, which is 9.8 centimeters, say, and we know the opposite angle here, and we'll just say that's about 70 degrees. Okay? Now, how does the sine rule fit into this? Well, if we apply the sine rule, what you do is when you're finding an angle, just write sine of that angle, in this case theta, divide it by the opposite side. In other words, for this example, 8.2. We compare the sine of an angle with the length of the opposite side. And this comparison or ratio is exactly the same as comparing another sine of an angle, in this case sine of 70, with its opposite side. So we compare that and we have sine 70 degrees compared with 9.8. Alright? So that's the sine rule when you're just trying to work out an angle. Now we have an equation, and all we've got to do now is rearrange this equation to eventually work out what theta is. So to do this, what we need to do is multiply both sides by 8.2. So if we multiply this term here by 8.2, we're just left with sine theta. And if we multiply this side by 8.2, you could put times 8.2 on the end, but personally I prefer to write numbers in front of trigonometric functions. So I'd write 8.2 times the sine of 70 degrees. And then we divide this by 9.8. Now you can divide just the sine 70 by 9.8 or the whole of the top there by 9.8. It wouldn't matter, it just gives you exactly the same answer. Now if you work this out, make sure your calculator's in degrees mode because we're handling degrees here. You should find that this comes to 0.7862 and so on. So that's what sine theta is, but we want the angle theta. So to get the angle theta, we need to remove the sine here. And to do that, we take the inverse sine of both sides. If you take the inverse sine of this side, you're just left with theta, and if you take the inverse sine of this side, we write down the inverse sine of 0.7862 and so on. And again, make sure your calculator is in degrees mode, and if you type in this function, you should end up with 51.838 and so on. And that's going to be degrees. Now if we're to give this to a suitable degree of accuracy, then I would suggest no more than say 1 decimal place, or the equivalent of 3 significant figures here. It's going to come to 51.8 degrees to 1 decimal place or 3 significant figures. Okay, well let's just try another one. Okay, I hope you got that idea. And here's a triangle. We've got to find out the angle theta here. We've got opposites, okay, we've got the opposite side 5.2 meters, we've got this pair here, we've got an angle and its opposite side 4.8. So this should be another simple example then, just like this one. we might like to pause the video and give this one a go and come back in a moment and just see if you've got the right answer, or if you're stuck, you'll see how I've worked it out. Okay, well, let's just see how you got on. We'll just rule that off so we can give this space. So it's going to be very similar then to the one we did up here. We've got the angle and its opposite side, and we've got another pairing here, an angle and its opposite side. So we can go straight into the sine rule and say that we've got sine theta compared with or divided by its opposite side, which is 5.2, and that's going to equal the sine of 64 degrees compared with its opposite side, 4.8. So just rearrange this, multiply both sides by 5.2, and we therefore have that sine theta equals 5.2 multiplied by the sine of 64 degrees, and that's divided by 4.8. Again, make sure your calculator is in degrees mode. Do this sum and you should find you get 0.9736 and so on. So in order to get theta, what we've got to do is take the inverse sine of both sides, and we end up with theta equals the inverse sine of 0.9736 and so on. And if you do that, you should find that you therefore have theta equals 76.828 and so on. And if we round this up to a suitable degree of accuracy, say again 1 decimal place, you're going to get 76.8 degrees to 1 decimal place. Okay, well, I hope that gives you some idea then how we can use the sine rule to find out an angle. And this is all summed up in a formula which you'll see in most textbooks or on a formula sheet, and it's given like this. We take a triangle and we label the angles capital A, capital B, capital C, and the sides opposite these angles are denoted by small letters. So we have little a being the side opposite angle A, little b being side opposite the angle B here, and C, this length here, being opposite the angle C. And we write this formula as sine of any angle, A in this case, over its opposite side, is exactly the same as comparing sine of another angle, say B, over its opposite side, is exactly the same as the sine of another angle, C, over its opposite side. And all we need to do is just take any pair of these comparisons, these ratios if you like, as I've done here and here. Okay? Well, I hope that, as I say, gives you some idea and you can work out similar examples, setting them out along these kind of lines. Okay, well, that brings us now to the end of this tutorial.